Okay, I think most of statements already identified in last lecture. So I think what is statement? First statement. If U is homogeneous function of degree n, it is homogeneous function of degree n. That is already we defined what is homogeneous function and how we find the degree of homogeneous function. That is u of xt yt is equal to some power of t into function itself, u as function of two variables, then x del u by del x plus y del u by del y is equal to n into u, where n is the degree of homogeneous function. This is the first order. And second order, x square del 2u by del x square plus 2xy del 2u by del x del y plus y square del 2u by del y square is equal to n into n minus 1 u. The first statement, when u is homogeneous of degree n. Okay. Mostly we use first statement when u is algebraic function. When u is algebraic function, then directly we find the degree of such algebraic function. But in few cases, if u is not algebraic function, if u is given in terms of logarithmic, exponential or any inverse trigonometric function, then we use here second statement. Means if function of u is homogeneous of degree n, then x into del u by del x plus y into del u by del y is equal to n function of u upon derivative of function of u. Now in second statement, u is not directly homogeneous. Now we need to define function on u, and if function of u is homogeneous of some degree n, then we use function of u to find the first order derivative. Similarly, second order derivative, that is u xx means x square u xx plus 2xy uxy plus y square uyy is z of u into z dash u minus 1. Here we use z as a function of u function z, and this g is there by using function of u, where z of u is n into function of u upon f dash of u. Okay. For the second order, we use again function of u, only we introduce new function z here, and z is there by using function u, n into f of u upon derivative of function of u. Use this to use the second order derivative and first order derivative by using function of u itself. We use second statement. When we use second statement, when u is function of, or u is given in terms of algebraic form or trigonometric form or exponential form or logarithmic form, then we use second statement. What about first statement? First statement is for algebraic only, is it? So you may add one note how to identify Statement 1 and statement 2. Statement 1 and statement 2 identify identity. We just take one note. Note number 1. Use first statement. Use statement 1, that is first statement. Use first statement or rule 1 आप बोल सकते हो उसको. Rule 1 और statement 1. Use rule 1 if u is algebraic function. U is algebraic function. Okay. Use rule 1 for first order as well as second order. Okay. Then U is algebraic function. And second note, use rule 2 if U is not algebraic. That is, U is one of the except algebraic. U is one of the form except algebraic means trigonometric, exponential, inverse, logarithmic, okay, etc. It is not algebraic means it is one of the form except algebraic, trigonometric, exponential, inverse or logarithmic. These two statements when U is function of two variables. If U is function of three variables, we use the next two statements. First two statements for two variables. If U is function of only two variables. Statement 3. If is homogeneous function of degree n, if U is homogeneous function of degree n, that is how we find a degree by using the substitution x is equal to xt, y is equal to yt and z is equal to zt. If we get some power of t into function of u itself, then n is the degree of u. If u is homogeneous function of degree n, that is, this is how we find the degree of homogeneous function, then x ux plus y uy plus z uz is equal to n into u. X ux plus y uy plus z uz is equal to n into u. That is x del u by del x plus y del u by del y plus z del u by del z is equal to n into u. Now using third statement for three variables, we find only the first order derivative. Third statement is not applicable for second order derivative since u is function of three variables. In first statement, u is function of two variables. So here we find first order as well as second order derivative. But in third statement, only this Euler's theorem is applicable for first order derivative, not for second order derivative. Means from third statement, we get only the first order derivative, sum of first order derivative, and it is n times u. Okay. Similarly, one more statement is there. If u is not algebraic, if f of u is algebraic, or you may say here homogeneous, function of degree n, then x ux plus y uy plus z uz is equal to n into function of u upon derivative of function of u. Okay. Again here first order derivative, if u is not algebraic, then we use here function of u. Now we define function of u on it. If u is function of three independent variables, so x ux plus y uy plus z uz is n into function of u upon derivative of function of u. Statement number 3 and statement number 4 for three variables function. For three variables, it is a function of three independent variables. And first two statements are there for two variables only. If u is function of xy, use either first or second statement. If u is function of three independent variable, then use third or fourth statement. Depends on given function. It is algebraic. Statement 1 or statement 3. If u is not algebraic, but f of u is algebraic, then use statement 2 or statement 4. आपको फर्स्ट आइडेंटिफाई करना है और उसके बाद यूज करना है डेरिवेटिव्स। एक एग्जांपल, if u is examples, if u is cos inverse of x cube plus y cube, if u is cos inverse of x cube plus y cube, then find x ux plus y uy and x square uxx plus 2xy uxy plus y square uyy. If u is cos inverse of x cube plus y cube, then find x ux plus y uy, first order as well as second order derivative. Now let us assume here u as cos inverse of x cube plus y cube. Equation 1. You are given function u is inverse function. U is given in inverse form. Is it homogeneous? Is it homogeneous? Homogeneous है U is equal to cos inverse of x cube plus y cube. Is it homogeneous? U initially is not homogeneous since U is inverse function. Now we need to define function on U which is homogeneous. So to remove the inverse sign, apply cosine to both sides. So applying cosine to both sides, we get cos of U is equal to cos of cos inverse. What is it? X cube plus y cube. Now this is your function of U. Cos of U means function is defined on U. Means f of U is cos U. Now see here, f of U is x cube plus y cube. Means f of U is algebraic. Initially U is not algebraic, but f of U is algebraic. Let us assume it as equation number 2. Okay. Now it is homogeneous. Okay. And now we find the degree. Put x is equal to xt, y is equal to yt in equation 2. So f of u is equal to xt cube plus yt cube. So the cube of x into t, x cube t cube plus y cube t cube. So t cube is the common term into x cube plus y cube. So here we get a function of u after the substitution. F of u is equal to t cube into function of u. Okay. What is the power of t here? 3. So what is degree then? So f of u is homogeneous of degree 3. N is equal to 3. Okay. Now once we have a degree of homogeneous function, use Euler's theorem for first order as well as for second order. Okay, U is function of two variables. So use statement 1 or 2. कौन सा यूज करेंगे अब यहाँ पे आप? Statement use U करेंगे 1 करेंगे या 2 करेंगे? 1 is not applicable because U is not directly homogeneous. F of U is homogeneous. So statement number 2 or rule number 2. So by Euler's theorem, x into ux plus y into uy is equal to n into f of u upon f dash of u. So put n and function. So n is 3. Function of u is cos u. And derivative of function, as we know the derivative of cos, what is it? Derivative of cos minus sine. So minus 3 cot u. X ux plus y uy is minus 3 cot u. This is the first order derivative. That is first term जो आपको find करनी थी यहाँ पे. This one. Okay. Now by using the same statement, what is the second order derivative? X square uxx plus 2xy uxy plus y square uyy is zu into z dash u minus 1. Yeah. Let us assume it as equation number 4. What is ZU here? ZU is n into FU upon F dash of U. So 3 into, here already we find this value, n into FU upon F dash of U, that is from equation number 3, it is minus 3 cot U. ZU is minus 3 cot U. Now what is the derivative of U, ZU? Derivative of cot, as we know, minus cosec square. So minus minus plus, so it is 3 cosec square U. Now once we have Z and Z dash, put it in equation 4. Put Z and Z dash in equation 4. So we get x square uxx plus 2xy uxy plus y square uyy is equal to minus 3 cot u into 3 cosec square u minus 1. This is your second term. Yes. Using Euler's theorem, we already have x ux plus y uy as n into function of u upon f dash of u. Here function of u is cos. So 3 into cos u upon derivative of cos is minus sine, and as we know cos upon sine is cot. So the first order derivative, sum of first order derivative is minus 3 cot u, and the second order derivative by using same statement z of u into z dash of u minus 1. So z of u by using equation 3, derivative of cot is minus cosec square. So after using these two values z and z dash, we get a second order derivative, sum of second order derivative by using Euler's theorem. Now here, no need to find first order and second order derivative. Similarly, no need to find second order derivative with respect to x and y. Directly यहाँ पे within 2-3 steps using Euler's theorem we get the value of derivative. Okay. Initially, that is by using definitions we need derivatives, but here there is no need to find the derivatives. But how we identify कि यहाँ पे Euler's theorem use करना है या general definition use करनी है. So whenever sum is in terms of, or derivative is in terms of the sum of both x and y. Similarly, derivatives of second order in terms of sum of x and y, then and then use Euler's theorem. Otherwise, no need to use Euler's theorem. Directly use definition. Definition of differential. First order, second order, third order, fourth order, like this. If ever डेरिवेटिव इज नॉट इन टर्म्स ऑफ सम, अलग अलग है तो आप वहाँ पे डेफिनेशन यूज करेंगे, सम में टर्म है तो आप यूलर्स थ्योरम यूज करेंगे. ठीक है, गेटिंग इट? टेक वन मोर, दिस वन, लास्ट स्लाइड. Next example. If u is x cube plus y cube plus z cube upon root x plus y plus z. U is x cube plus y cube plus z cube upon root x plus y plus z. Then find x del u by del x plus y del u by del y plus z del u by del z. That is x ux plus y uy plus z uz. So let us assume here given function x cube plus y cube plus z cube upon root x plus y plus z as equation 1. Now it is asked partial derivatives and the sum of partial derivative is asked ux plus uy plus uz. Separate partial derivative हमें नहीं फाइंड करना है. So whenever separate partial derivatives फाइंड करना होता तो आप क्या करते हैं डेफिनेशन यूज करते हैं. Now here first order derivatives with sum is asked x ux plus y uy plus z uz. So अलग से डेरिवेटिव फाइंड करने की आपको क्या करना है एडवर्स थ्योरम का यूज करना है. It is function of three independent variables x y z. Statement number 3 और statement number 4. तो statement number 3 कब यूज करेंगे statement number 3 the given is homogeneous. Statement number 4 when initially it is not homogeneous. तो हमें चेक करना है कि ये homogeneous है या नहीं है. What is u? U is x cube plus y cube plus z cube upon x plus y plus z, root x plus y plus z. So your initial function, that is u is algebraic function. कौन सा function है? Algebraic function. इसका मतलब ये homogeneous है. अभी क्या बचा है? Degree बची है. So we find the degree by using the substitution x is equal to xt, y is equal to yt and z is equal to zt. Initially u is homogeneous. Why it is homogeneous? Since it is given in algebraic form of variable xy. Now put x is equal to xt, y is equal to yt and z is equal to zt in equation 1. So u of xt, yt and zt is xt cube plus yt cube plus zt cube upon root xt plus yt plus zt. From numerator take t cube common. So the remaining term is x cube plus y cube plus z cube. And from denominator take root t common. So the remaining term is root x plus y plus z. Okay. So that is t cube. And this 1 upon root t becomes t to the power minus half. 1 upon t to the power half becomes t to the power minus half into x cube plus y cube plus z cube upon root x plus y plus z. When base is same, take the addition of power. So 3 minus half. 3 minus half. T to the power 5 by 2 into u of x, y, z. uxt, yt, zt is equal to some power of t into ux by z. So what this implies, u is homogeneous of degree n is equal to 5 by 2. Okay. Degree power of degree. It's a degree. So u is homogeneous of degree 5 by 2. Now once we have degree of homogeneous function, use the degree to find the first order derivative by Euler's theorem. So by Euler's theorem, x ux plus y uy plus z uz is equal to n into u. Statement 3. Statement number 3. So put n is 5 by 2 and u is given function x cube plus y cube plus z cube upon root x plus y plus z. Means within one step, here we get the value of sum of the partial derivatives. Now using Euler's theorem. And this is your RHS. Okay, 5 by 2 x cube plus y cube plus z cube upon root x plus y cube plus z. Okay, one more. If u is x to the power 1 by 3 plus y to the power 1 by 3 upon x to the power 1 by 4 plus y to the power 1 by 4, then find x ux plus y uy and x square uxx plus 2xy uxy plus y square uy. If u is x to the power 1 by 3 plus y to the power 1 by 3 upon x to the power 1 by 4 plus y to the power 1 by 4. Then find sum of first order derivatives and sum of second order derivatives. So first check whether u is homogeneous or not. Let us assume u as equation 1, x to the power 1 by 4 plus y to the power 1 by 4 as equation 1. If it's algebraic function, it is homogeneous. So find the degree. So for degree, use the substitution. X is equal to xt, y is equal to y. Now we have only two variables, so the substitution is also up to the two variables x xt, y yt. So here we get u xt yt as xt to the power 1 by 3 upon xt raised to 1 by 3 1 by 4 and here yt to the power 1 by 4. So from numerator, take throughout t to the power 1 by 3 common. So the remaining terms are x to the power 1 by 3 plus y to the power 1 by 3. Upon from numerator denominator, take t to the power 1 by 4 common. So the remaining term is x to the power 1 by 4 plus y to the power 1 by 4. So t to the power 1 by 4 becomes t to the power minus 1 by 4. Of x raised to 1 by 3 upon x raised to 1 by 4 plus y raised to 1 by 4. One upon 3 minus 1 upon 4. What is it? 1 by 12. So t to the power 1 by 12 of uxy. When base is same, then take the power का additions करना है. So it gives 1 by 12. So the power of t is 1 by 12. Means u is homogeneous of degree 1 by 12. Okay. So once we have degree, use directly statement. कौन सा यूज करेंगे यहाँ पे? फर्स्ट वाला, सेकंड वाला, थर्ड वाला या फोर्थ वाला? First statement, because U is homogeneous. So by Euler's theorem, x ux plus y uy is n into u. So put n and u. N is 1 upon 12, that is degree, and u x to the power 1 by 3 plus y to the power 1 by 3 upon x to the power 1 by 4 plus y to the power 1 by 4. So this gives first one, and second one, x square uxx plus 2xy uxy plus y square uyy is n into n minus 1 u. These statements already we defined. Put n, that is 1 by 12 into 1 by 12 minus 1 of u. U is x to the power 1 by 3 plus y to the power 1 by 3 upon x to the power 1 by 4 plus y to the power 1 by 4. So 1 upon 12 minus 1 minus 11 by 12. So minus 11 by 12 into 1 by 12 is minus 11 by 144 of x to the power 1 by 3 plus y to the power 1 by 3 upon x to the power 1 by 4 plus y to the power 1 by 3. So this gives first order as well as second order. This is how we use Euler's theorem to find or to solve system of equations. Let us take one more. If image image tan inverse of image equal to next example. X cube plus y cube upon x plus y. Then prove that U is tan inverse x cube plus y cube upon x plus y. Then through that x square uxx plus 2xy uxy x square uxx plus 2xy uxy plus y square uyy is equal to sin 2u to 1 minus 4 sin square u. U is tan inverse of x cube plus y cube upon x plus y, then through that this one.